Hey, in this one, we're going to talk about why you see this suspicious S in the sudo permissions when you run LSL on it. Because yeah, if you run this on any other executable, you will see an X here, but there is a thing in Linux called a special permission bits, which are an additional 3 bits of before the usual permission, so read, write, execute for user, group, and other, which we usually see there. And what this S mean here, it's the setuid bit, special bit. And so what this means, if you apply that on a file, is that when you run the file, when you execute the file, if it's an executable, you will become instead of running it as your user, you will become the user of the file. So in this case, root, which is obviously, you can see how this is useful for sudo, because a regular user can run sudo, but actually when the program executes, it will be run as root, even though it's your user who started it. And so I have a very tiny example here. So I have a little main like this, which basically just prints the UID. So this is the real UID and the effective UID. The difference between the two is the real UID is the user the actual user running the file. And the effective UID is like how it will be considered permission-wise when you do stuff in this executable. So if you remove a file or if you create a file or anything, it will use the effective user ID, not the real one. And so I compiled it already, and if I run it as my regular user, you will see that both of those UIDs is 1000, which is the UID of my user. But I've also I've copy-pasted this a.out into root a.out, and then I just added the setuid bit on it with just a chmod, like so. So this is the way you set it, by the way. You just say for, like this, before the other regular permissions. And now if I run the root a.out, you'll see that my real UID is still 1000, just because this is the user I ran it with, but the effective UID is 0, so I'm root, basically. Like when I run this executable, everything that happens within this executable will be considered as if root ran it, and I didn't have to type a password or anything. I don't have any special link between me and root that allow this. It's just with the permissions. So yeah, that's why when you do ls on sudo, there is this special setuid bit, and it's the same on other like special commands like su. You will see that it also have this, or there is a do as, which is the FreeBSD, I think, version of sudo, also has this special bit. There is also other special bits. So this is the most important one, because if you have executables that have this special bit, especially if they're the owner of this file is root, that means that any vulnerability in these files can be exploited, and all of a sudden you can be root. So this is why like sudo is it's very important that sudo doesn't have any flaws, because if it does, that just means that someone can become root at any time. That's also why they created some people switch to doas, like me, because it's a much smaller code base. So like the area of possible vulnerabilities is much smaller. But anyway, there's another one as well called the setgid bit. So this is the exact same as the setuid, except that you will see it on the group level, like this. And so this does exactly the same thing, but instead of becoming the user, of changing the effective user, it will change the effective group. So in this case, the wall command, never used it before, but apparently it's supposed to broadcast a message to all the user connected on TTYs. And you see that it's owned by the TTY group. So I assume you can have some special permissions on the people's TTYs, and you can broadcast a message like this. Uh, this I don't see used too often, but it's still cool to know that it exists. And finally, the last one, which is much more important, is called the sticky bit, which is, I don't know, it's a weird name. I don't understand why it's named like that, but the best example I have for it is the TMP folder. So you see now we have a T at the end of this of these set of permissions in the TMP folder, and what this means uh, is that anyone can create a file on there, but like if the file belongs to another user, you cannot remove or rename the file. So for that, to showcase a bit what it does, I just created a user Bob, and so what I did is I just went into TMP and I created Bob's file here, which has it's just read only for other users. So Bob can write it and read it, and the other user can still read it, like so. But if another user, like me, for example, tries to remove Bob's file, it will not work. So yeah, that's mainly it. And similarly, if I create a file in the TMP folder called foo, Bob will not be able to rename it or remove it. And the only case where I see this being useful is in the TMP folder, since you want like every user to create random files in there, but you don't want other user interfering with other users' files. But yeah, anyway, so that's all for the sticky bit. Anyway, I think that's all I have to say about those special permissions. Seems a bit hacky, but still fun. The main one that is interesting is, of course, the setuid bit, which we have to be careful about and is also good to know. But yeah, if you see some S or T's in your permissions, next time you run ls, at least you will know why now. So anyway, that's all. See you in the next one.